So hello everyone, welcome to Arcade Technologies. And so today we are going to go with the next part. So we are going to state about the modules. The second module, that is state management. What is state management? And then we will go with the variables and outputs. And then one more session we will go, that is modest modules in Terraform. So after completing these three, I will have one more. We will perform one more lab that's related with the lab this course. Okay, so what is state management? Okay, so if the Terraform is the engine, the state file is memory. So if you remember, when we apply Terraform apply command, right? So after applying that command, we will get tf state, I mean .tf state file. So that is the uh, your current configuration. It will get saved. That is a state file, it's memory. Understanding the state what separate from. Okay, so what is state file? When you run Terraform apply, Terraform create a file called terraform dot tstate, a JSON file, right? So in your main .tf you will give configuration details. I mean, you will give your like provider, resource, modules, and when you hit apply, so it will create a tf state uh, tf state file with the exact instant ID, or maybe the resource name or IP address, IP name. So that all the names you will. What will happen? Purpose, it maps your real world resource like AWS instant ID to your code. AWS. See what is trying to say? It will add your AWS instant ID to your resource. We always in our main.tf we give our resource name, right? So it make connectivity. So why it is needed? Mapping, metadata, performance. So Terraform must know the resource and its server. So Terraform need to know the server. The resource is AWS instant.web in your code. It's the server with the instant ID in this AWS, right? Metadata. So it's store data not available in your code, but as dependency other enterprise reports. Yes, it store the metadata as well. Performance, for large structures, Terraform queries the state file instead of Cloud API to check the current settings. Yes. So when you see if you enter Terraform show, it will not go to the API. It will just go to the tf.state file and see the performance of it. So next is local vs remote state. So this is very important one. Local state means that when we get this tf state file, it is saved in your local laptop. Okay, so it is easy, like when we start learning about the Terraform. So it is always best practice to verify the tf state file. What are the files you can see? I mean, what are the files names and what are the, so you can verify. So for single user, it is good. So that is the pros, and cons is dangerous for team. Yes. If two people run Terraform at the same time, they might override each other changes. Also, state file may contain sensitive information in plain text. So that's why we should never store when in production, or if you are working in an organization, you should not save your state file in your local laptop. Okay, what we can do? We can store that state file in your remote state. So that is remote location like AWS S3, Azure Storage, or maybe HashiCorp. So any third party, or even GitHub or GitLab like that also you can use to store your tf.state file. What is the advantage? I mean pros. So that the same tf state file you can share with your team and safer storage. But always use, so that is you can see here. Best practice, always use remote state for your production. So if you go with any organization and ask you to store your state file in your local laptop, you should avoid that. You have to say that it's always good to have your state file in the remote location. Now, state logging. What is state logging? So, uh, imagine like here is mentioned, like imagine you are your colleague and both run Terraform apply and same at the same second. This will correct your state file. That's right. Like when two user applying the same command, so definitely it will corrupt, right? So logging is when you use a remote backend like AWS with Dynamo, Terraform log the state file during an operation. So what is that? You are logging it. You are logging that tf state file. So like any if two user, if anyone want making changes, it doesn't affect immediately. What it shows, if you try to run apply when it is logged, you will get an error occurring with the state log. That the error you will get, right? So so here we have the practical, like how we can configure it. So as I said, instead of we are telling this, uh, we are we are telling that .tf file need to be under the bucket. So what we are doing, Terraform, we informing the Terraform to use the backend S3 storage bucket. Okay, that is in the AWS bucket name key prod.app.tf the file path inside the bucket region. This is the tf.state file which we have, right? Region dynamonies and encrypt true, encrypt state file at rest. So that is you are encrypting it. You encrypt means you are encrypting that file, so it should not be read by anyone. And you are also used for state locking. You are locking this file using the Terraform locks. This is the so you have stored in the S3 bucket, okay, in this region, and you have logged it with the encryption. This is the right. This is the configuration of a remote backend in AWS. Okay. So next we go with the module three, that is variables and outputs. So see, we can manage state. We need to make our code reusable, right? So in Terraform, it's not like for every time you need to type coding from beginning for number of resource if you need. So for that we use variable and output. So you don't need to write the code again and again. You can use the same variables and output in multiple uh, location. I mean multiple time also you can use without rewriting it. So it's called reusable, right? Like instant type equal to type t2 dot micro is a bad practice. So like in some code we can give assigning, right? It's a parameter and here is the value. So this is the bad one. Instead of what we are going to do, we use variables. So how let's define it, they are defining the variable. So usually variable done in variable dot tf. So make sure if you go to get any question like how you assign variable, so you always used to inform we use variable module that is variable dot tf, and in that we declare the variables. So for example here variable equal to instant type. What is the instant type? Description, the size of the servers, type string, and default is T2 micro. And we are saving its name. Now, here, so now we are going to use that uh, variable, right? So resource, AWS instant web, image name is one, instant type, var dot instant type. What we have here is the variable we had declared, right? So we are calling this variable here, var dot instant underscore type. So it will go here. It will see this is the description, the size of the server. What is the default? T2 micro, right? So there is no need to change anything entirely. You just need to go to the um, if you want to change the size difference, so you can change it. Setting variables value. There are multiple ways to assign values to variables. Terraform load the value in a specific order of precedence. Highest priority wins. So highest priority, which will have the most high usage. Command line frag var equal to instant type equal to 3 to medium highest priority. T3, right? Command line fragment hyphen var. Start auto.tf files. File ending with auto.tf. Terraform.tf, the standard file for defining. And then environment variable tf var instant type t to 3 medium default lowest. Default value lowest. Okay, so here common question we get, if you have your default value of a and Terraform tf dot value, which just is go with the C. Default value go with last. Here it like this, if you are giving the value that it will take the highest priority. Hyphen var instant type equal to 3 dot medium. But here if we have declared it equal to default, right? So it is the least priority. But if you give instant type equal to var hyphen var dot instant type equal to 3 t3 dot medium, so it will take as a highest priority. Okay, so make sure this is the interview. How default A and B, which will we have? So terraform.tf vars will have the highest priority. Now output value. Okay, so think of this as a return value or print statement. Yeah, it's like a print statement. Like after this output, what will be the output you will get? So they allow you to get the out data out of your Terraform configuration after running it. Example, after creating a server, you need this IP address to SSH into it, right? So you know the IP until the server is created, right? So once the server is created, then only you know the IP address, correct? So output server IP value description the public address Terraform apply. So he in this output file you will get the IP address um, of that server, public IP address to connect with the SSH printed out in your terminal. Yeah. So I mean whatever like once it's applied, you can if whatever you output module in and under the output module you give, right? So that will print after the apply command. So local values are like temporary variables used inside your code to simplify complex logic. Okay, for example, common tags project equal to environment equal to var dot environment resource. So here we are giving the local common tag project. It's a website environment is var dot environment resource. So it tag from here we are assigning it will get local dot name. Here we'll go to it and get the tag name, right? So what we have learned? We have learned variables, output, locals, and there's a predecessor that flags tf dot tnv dot tor. Now coming to the modules. So you had putting everything. Yeah, that's right. So modules is like it's above one only. So everything in putting main.tf is not manageable and it's not recommended. That's modules comes. So modules contain. There are two types of modules. One is root module, child module. The directory where you apply Terraform apply, that is the root module. And if any module refer to another module, that is child module. Okay. So instead of copying pasting code of a web server fiber, you write it once and modules and call it anywhere. So that, as I said, it's like you're copying. You need to write once and you can call it from anywhere. You can use a module block. The one mandatory argument it is source. We will have example local path source equal to this is the directory path Terraform registry. This is the see if you're giving if you're assigning locally, so you this is the command. And if you're taking from the Terraform registry, so gross source equal to Terraform AWS modules. So these are the you're taking the modules. It's downloading the modules from the Terraform registry. Otherwise, if you have it on Git, so you can give source Git, then GitHub infra dot modules. So whatever the modules inside it, it will get instance. So how do you version your module? So when we use Git or registry, you can specify the version or tag to ensure your website does not break it. Module author change the code. Yes. So when you want to ensure that your code does not need to be break, so always need to, it's good to have versioning it in registry or Git. So resource scope and encapsulation. Resource inside your modules are isolated. Variable output. The child module cannot see the root variables unless you pass them explicitly. Right. So child module we can't see the parent value. Output the module cannot the child resource like in instant ID unless the child explicits out the same. Root module cannot see the child resource unless the child explicits outputs them. Okay. So that's it. I will share this over the comment or over the my channel, so you can go through it to get it more. Next, we will perform one lab related with the modules, so you will get more knowledge on it, and that lab will be from googleskillpartner.com. So okay, so let's see. Thank you.